Good afternoon.
Good afternoon.
So how's everyone?
Pretty bummed out.
Bummed out. What's going on?
Nothing.
That's why you're bummed out?
Yep.
All right. Well, I'm not sure if calculus is really the answer. Some days it is. I know when I'm bummed out and I feel like I can't control life and I'm depressed and math makes sense. So then it helps. I don't know if that will help you or not. But anyway, so let's see. So Chloe and Skylar, were you guys able to finish that test?
Yeah, we did finish it. Thank you.
Well, thank you for having patience with me. I got trapped in a meeting, and anyway, it wasn't one of those where I could sort of pull out my computer and start opening up tests. So I felt really bad about that. So
It's all right. It worked out. Thank you.
okay, good. All right. Well, let's see. So today we are going to finish 4.3 and maybe start on 4.4. Let's see here. Okay. So
John.
Yes.
Yeah, real quick. I had a problem I was doing in the book, and I could not figure it out, and I was wondering if you could possibly help me out.
Go, fire away. Where is it?
Okay, so it's on page 1. Do you have the book?
Yep.
Yeah, okay. It's on page 163, number 34. The one with the cone and the cylinder coffee pot.
Sure. 163. Number 34. Oh, so related rates. Okay. All right. Okay. So let's so this one's on making coffee. I'm not an expert by any means, but let's see if we can do this problem. So this is on 3.8, number 34. So it says coffee is draining from a conical filter into a cylindrical coffee pot at the rate of 10 cubic inches per minute. Okay, so that's the dVdt. Okay. All right, so how fast is the level of the pot rising when the coffee in the cone is 5 inches deep? How fast is the level of the cone falling then? Okay. How fast is the level in the pot rising? Okay, so here we're going to have to deal with two formulas on this one. So we've got the cone, and it's the volume of a cone is 1/3 pi r squared h, and then the cylinder, the pot, its volume is pi r squared h. Okay. So now in both of them, it looks like, well, let's see. So in the cone, the radius is 1/2 of h. So the radius of the cone is 1/2 of h. And it looks like in the cylinder, the radius is the same. It's not changing at all. The radius would be 3. Okay.
Mr. Strong,
Yes.
how do you get the radius is 1/2 h?
Because the radius of the cone and the diameter is always the same. The radius and the height is, or excuse me, see where it says, okay, in the picture, see it's got the radius and the height of the cone are the same, 6 and 6. So with a cone, it's always, that proportion will always be the same. So the diameter and the height is the same. So then that means, like, when it's at any level right here, like if this is 3, then this would be 3. So the radius is going to be equal, or excuse me, the diameter across of whatever the surface is going to be equal to the height at any point. So that means the radius is going to be half of the height. And the reason why I'm doing it in radius is because the r and the h are together, not the diameter. So I wanted this, I didn't want d equals h, I wanted r equals 1/2 h. Okay? So do you see that relationship's going to be true no matter what the height is of the liquid, okay, of the coffee. Okay?
And is it that to every single cone, no matter what?
That's every single cone has that property.
Sweet.
Okay. All right, so let's see. Okay. How fast is the level pot changer when the coffee in the cone is 5 feet deep? All right. So let's just say, okay, when the coffee in the cone is 5 inches deep. Okay, so let's go ahead and do the related rate here for the cone. So that would be dV dt. Oh, wait, let's substitute in r equals 1/2 h. Let me back up. Okay, so I'm going to have V, oops. So V equals 1/3 pi. And then I'm going to plug in place of R, 1/2 H. So I get 1/2 H squared times H. So we better simplify that. So we get V equals 1/3 pi. So this is 1/4 H squared times H. So I get V equals 1/12 pi H cubed. All right, so that's a little trickier than most of the problems. We were just given a formula and then had to run with it. All right, so now this one, when we take the derivative, so dv dt is equal to, okay, so bring the 3 in front, so 3/12 is 1/4 pi h squared dh dt. Okay. All right, so now, so how fast is the level in the pot? Okay. Let me think this out. When the coffee in the cone. Okay, so the cone is 5 inches, so that's H. Okay, we know dv dt. So the level, okay, so the dv dt is 10, but it's coming out of the cone, so it's going to be negative. Right? So this, put in negative 10 here, equals 1/4 H and pi, excuse me. Pi and 5, when the cone is 5 inches deep, so 5 squared times dh dt. So that is going to tell us when we solve that for dh dt, that will be actually the answer to part B. How fast is the level in the cone falling then? Okay. So when we do the math on that, that's going to be the change in height of the cone. Okay. All right. So how fast is the level? All right. So how is that going to help us answer part A? Let's see. Well, let's see. So this dv dt, here, let's do this in a different color here.
Bless you.
Thank you. So this dv dt, and you can even call, well, okay. So here the radius of the cylinder is always 3. So that's not changing at all. So I think we can just put that in as 3. So that would be V equals pi times 9 times h. So dv dt would be 9 pi dh dt. All right, and so in this case, dv dt is going to be positive 10. So 10 equals 9 pi dh dt. And so this is actually the change in height of the cylinder. So it would be 10 divided by 9 pi. So 10 divided by 9 pi is dh dt. So that's the change in the cylinder. And then this would be the change in the height of the cone. So let's see, this would be, oops, come on. All right, so this would be negative 10 equals 25 pi fourths dh dt. And so then to solve for dh dt, if I did negative 40 over 25 pi, and 5 will go into each of those, so negative 8 over 5 pi. So that's the answer to part B, and that's the answer to part A, the red. So sorry I did that a little backwards, but that's kind of how I was thinking.
No, that was perfect. Thank you.
Okay. So really, I think a couple of things there. Number one, understand the relationship between cones. How no matter what the level is, they form what are called similar figures. And so that ratio of height to radius is always the same. Okay. And then the second thing, I think the key here is if the coffee is draining out of the cone into the cylinder, then its dVdt will be negative, and the dVdt in the cylinder is positive. Okay.
Mr. Strong, what was the
Yes.
change in cone come out to again?
The change in the height of the cone would be
So you have the dVdt and then just down at the bottom. Okay.
so then you solve for dH/dt. That's the change in the height. So negative 8 over 5 pi. Okay, and frankly, that's I actually kind of like it when you ask me a really hard one like that, because that one is harder than what I would give you. Okay, because I wouldn't have two in the same problem. Okay, but it's cool. All right. So, are there any other ones? Any other questions on anything in those first three chapters? Going once. Going twice. All right, sold. Well, let's go ahead and get back to 4.3. So we do have, remember tomorrow and Thursday, we won't have a regular broadcast. We'll have the midterm during class time. All right? And just so you know, I will say this, is that my morning class, they already took the midterm. Okay? And I know some students were able to finish each part in like 30 minutes. Okay? Now, I'm not trying to make you overconfident or whatever, but I don't think I haven't picked the hardest problems in the chapters. So if you study well, have your notes handy, but don't feel like you have to look up everything, and then just check things over, I think you'll be fine and you'll do well. So far, I've been very happy with the scores so far. So I think you guys can go in there with some, cautiously optimistic. Like, you can do this. It's very doable midterm. Okay? All right. So, but it's during class time for everybody tomorrow and Thursday. And then what I'm probably going to do, what I'm hoping to do Monday before class is to go through and do the curve, and then I will adjust the scores based on the curve. Okay? All right. Any questions about that?
So are we taking the first half the first day and then the second the next?
Yep. That's
Okay.
exactly how it works. That's exactly how it works. So part 1 will be tomorrow, and part 2 will be Thursday during class time. So you'll all take it at the same time. And so I won't be broadcasting either of those days. Okay? And so it should tell you immediately what your score is afterward. Okay? Now, I know this sounds crazy, but I actually did have a student in my trig class that at the very end forgot to press submit. And so I'm kind of dealing with the idea that I can kind of see that she worked through the class score, but the Moodle's given her a 0. Okay? So don't do that. Make sure you submit before the time ends. Okay? All right. Any other questions?
How many questions are on the?
I think it's 15 each part. Okay?
Okay, thank you.
But now you only get one attempt. Okay? You only get one attempt for each part. Okay? So you no do-overs. Okay? All right. Okay, so let's go back to 4.3.
Hey, Mr. Strong, just
Yeah.
by the way, we can't see you right now. All we have is your chair.
Oh, you can't see me? Oh, brother.
No, sorry.
Well, you're missing my best side, right? Okay. There, that makes the teaching a little bit better. Okay, so I had asked you to go through and do this last practice problem on 4.3. So I'm just curious to see really what you could remember about solving trig equations. Okay, that's what I was really curious about. Okay, so what we're trying to do here is first we're trying to find the critical points. All right, so in order to find the critical points, we first need to find the derivative. Okay, all right, so let's start there. All right, so Skylar, what is the derivative of sine x minus cosine x?
Cosine x plus sine x.
That is correct. Okay. Now, to find the derivative, to find out where that's equal to 0, you set that equal to 0 and solve it. Okay. Now, sometimes when you have a trig function and you're trying to solve it, you can factor, you can do a lot of different things. Okay. But this is kind of tough because you can't really factor it. So what you have to do is actually kind of almost reason it through and say, where is the, bring one of these over to the other side and say, where is the cosine equal to the negative of the sine? Now, the thing that helps you on that is if you think, where is the sine and cosine equal? Well, that's in quadrant 1 at 45 degrees or pi fourths, and quadrant 3 is that it's radical 2 over 2. Both sine and cosine are radical 2 over 2 at 45 degrees or pi fourths. So at 3 pi fourths and 7 pi fourths in quadrant 2 and quadrant 4, that's where they're opposites. Okay? So the tough thing about this is you kind of have to remember that from the unit circle. And I was a little curious to see, did anybody remember that those were the angles where sine and cosines were opposite? Anybody remember that? I'm just curious. Okay. All right. And so at pi fourths and 5 pi fourths are where they're equal. Now, let's say that you didn't remember this or you didn't think to look at the unit circle. The way you saw, whenever you're given any equation in this class and you don't remember how to solve it, put it in the calculator. Put the left side in for y1, the right side in for y2, and see where they intersect. Okay? Now, it won't give you the answer in terms of pi, but it'll give you the answer in terms of, decimals. Okay? But you can deal with that. All right. So those are the critical points. Identify the intervals where f is increasing or decreasing. Okay, so how do we do that? How did we do that yesterday? How do we figure out where the graph is increasing or decreasing? Using the critical points.
The sign chart thing.
Yep, you do the sign chart. Okay? And it's the sign chart of the derivative. So we're going to be plugging stuff into the derivative. Okay? All right, so you're going to have your sign chart with 3 pi fourths and 7 pi fourths. And we're just going from 0 to 2 pi. Does it say that somewhere? Yeah, 0 to 2 pi. Okay? So what we need to do is check values in each of these. Okay? So, what we've got to do is, so what's a value between 0 and 3 pi fourths? What's an angle between 0 and 3 pi fourths over here?
1.
Well, remember we're doing radians. So, I mean, we could do 1, but you might not know 1 radian. Okay? I mean, but how about 1, let's see. Not 1 pi. 1 pi would be in here. So what would be between 0 and 3 pi fourths?
Pi fourths.
Okay, pi fourths. So what we need to do, so if we use pi fourths and we plugged it into the derivative, so cosine of pi fourths plus the sine of pi fourths, aren't those both positive? Sine and cosine of pi fourths? So if they're both positive, radical 2 over 2, plus radical 2 over 2. I don't even care that they're radical 2 over 2. What I want to know is that they're both positive. So I have a positive value plus another positive value. So this has got to be positive. Okay, so now we need an angle between 3 pi fourths and 7 pi fourths. So here's 3 pi fourths over here. Here's 7 pi fourths down here. So what would be an angle between those two?
5 pi 4.
What? Say it again?
5 pi 4.
5 pi fourths would work. Okay? There might be an easier one though. How about just pi? Okay? If we do pi, see 5.4, you can use your calculator. I'm trying to do angles that I can do in my head. Okay? All right? But 5 pi fourths isn't bad. I could probably do that in my head. But here, if I plugged in pi, what's the cosine of pi?
-1.
And the sine of pi?
0.
0. So negative plus 0 this has got to be negative. Okay? All right, now I need, between 7 pi fourths and 2 pi. Now that's not a huge difference there. So 7 pi fourths, so here's pi, 7 pi fourths is all the way down here. 2 pi is right here. So that doesn't give me much. But can you think of an angle that's between those two?
2 pi. Oh, wait, between them?
Between them.
11 pi 6.
11 pi 6. Okay? Now, so the cosine of 11 pi 6 is positive. The sine of 11 pi 6 is negative. So now it's a tug of war. We got to know which one's bigger. Okay? So this one, do you know? Or you could use your calculator. Which is bigger? The cosine is positive, the sine is negative.
It's the cosine, isn't it?
It's the cosine, because the cosine is radical 3 over 2, and the sine is negative 1/2. So the cosine wins in the tug of war. So it's going to be positive. All right, so now, based on that, where is the function positive? Or excuse me, where is the function increasing? Where is it decreasing?
It's increasing from 0 to 2 pi fourths, and from 7 pi fourths to 2 pi, and then it's decreasing from 2 pi fourths to 7 pi fourths.
Yeah, that's actually a 3. It's a lousy looking 3, but it's actually 3 pi fourths. Okay, so but yeah, so increasing from 0 to 3 pi fourths, and 7 pi fourths to 2 pi, decreasing here in the middle between 3 pi fourths and 7 pi fourths. Okay? So do we have any local maxes or mins?
There are 2 local maximums and 2 local minimums.
All right, so where is the first one?
Alright, so the first one is from 0 to 3 pi 4.
Now the local maximums are at a point.
At a
They're
point.
not an interval.
It's at 3 pi 4, and then
And so 3 pi fourths, is it a maximum or a minimum?
it's at a maximum.
Yes, because the derivative is going up, it's positive, and then 0, and then down. So that's a maximum. Okay? All right, and where else?
You have a local minimum at 7 pi fourths.
Correct. Okay? Because the derivative is down, negative, then 0, and then positive. So that's a local min. So that's the local values. So for the extreme values, that means the extreme max and mins, what you have to do then is make your chart. Okay? So let's see. Do I have a chart here?
Mr. Strong,
Yes.
I have to go to my interview now.
Oh, okay. All right. Thanks. Okay. So for your absolute min and max, there's where you have to check your endpoints, 0 and 2 pi, and your critical points, 3 pi fourths and 7 pi fourths. And then what you have to do there is figure out so now you're plugging into the original function to do the absolute max and min. So this is going back to 4.1. So you test your endpoints and your critical points, and you plug into the original function, not the derivative, and then you figure out which of these y values is the highest and which of them is the lowest. All right, so I'll give you a minute. Joey, when you get that.
Okay, so for the absolute maximum, I got the 3 pi fourths, and then for the minimum, 7 pi fourths.
Okay, that's it. Because you get radical 2 is the highest, is the biggest of all these. Negative radical 2 is the lowest. So it's 7 pi fourths. Okay? All right. So any questions on any of that? Anyone having trouble getting that? Want me to do it in the calculator, or anyone having any trouble calculating those values? And you could, of course, put those in the calculator. Make the calculator do a table for you.
Did we ever
Mr.
go
Strong,
Oh, yeah.
go for it.
Go ahead. Did we ever go over what?
the part where it says if C is a critical point of trigonometric function,
Then
blank?
C plus 2 in pi is also a critical point.
Okay.
So
Could
that's
you say that one more time?
That's why on this one I didn't want to have to deal with that. So that's why I restricted it from 0 to 2 pi. But otherwise, like if you've got a maximum up here for a sine wave, then every 2 pi it's going to be up there. And so it's also going to be a critical point. Okay?
So we put that in for the blank that on the part 3 of 4.3?
Yes.
So
So
it's
it's if C is for part 3, if C is a critical point of a trig function, C plus 2 in pi is also a critical point. So if you add 2 pi to it, you're going to get another critical point. So, or if you have a specific function where, let's say, if the period is shortened from 2 pi to pi halves or whatever, 5 pi, every time you have another period, you're going to get another critical point there. Okay? Now, I'm not really going to make a big deal out of that, but I'm just letting you know that if you have a max, you're going to continue having a max. All right? Any other questions on that? Anything else on 4.3? Okay, I think we're going to quit early today. You've got your midterm tomorrow. You got a lot to do. So let's just bail on 4.4. We'll start that next Monday. Okay? So text me, email me if you have any issues. But midterm part 1 tomorrow, part 2 Thursday. Good luck. And we'll talk about your grades on Monday. Okay? All right. Y'all have a great day. We'll see you.
See you, Mr.
You too.
Strong.
Bye.